This is section 7.6, quadratic functions. These are the graphs of parabolas, and we're going to be spending some time doing that today. Okay, the equation that we have been dealing with is y minus k equals a times x minus h. Now, in a real equation, k and a and h represent numbers. The vertex comes from the numbers subtracted from x and y, so h and k. Okay, how do you know if the parabola opens up or down? If a is greater than 0, if it's positive, it opens up. Looks like this. If a is less than 0, it opens down, which rhymes with frown, which looks like that. How do you find the y-intercept? Remember, the y-intercept crosses the y-axis, so that's where x is equal to 0, so you solve for y. And then, how do you solve for find the x-intercepts? They cross the x-axis, so let y equal 0, solve for x. And what is the axis of symmetry? The axis of symmetry is the vertical line through the vertex. And its equation is x equals h. And how can you tell if a parabola does not have an x-intercept? That's if x is imaginary when y is equal to 0. Now, a new form, which is not really new, but the function that we use is, we're going to use f of x instead of y right now. And we are going to go back to using the quadratic form. So ax squared plus bx plus c. We use this when we're using the quadratic formula to solve for x. So how do you find the vertex? It's a little different now. Now we're going to use b and a. So x is equal to negative b over 2a. And if you remember the quadratic formula, negative b over 2a is the beginning part of it. And then how do you find the vertex? Well, you're going to take whatever that value is that you found, negative b over 2a, and substitute it into the function. So that number will be substituted everywhere there's an x. And your vertex is the resulting x and y. The domain, what are all the possible x values for a parabola? Well, it's negative infinity to infinity, always. The range are all the possible y values, and that really depends on the shape of the parabola. If your parabola is pointing down, the maximum value is right here at the vertex. And so that is the maximum that you're going to reach. So you're going to begin at negative infinity and go up to that y coordinate. If you're facing up, like that, you're going to begin at the vertex and go up to infinity. So how do you know whether the parabola has a maximum or minimum? So is the vertex at the top or is the vertex at the bottom? Well, if you look here at this parabola right there, if you see, that is a pointing down parabola, which means that the a value is negative. So if that is less than 0, you're going to have a maximum. If it's greater than 0 and faces up, opens up, then it is a minimum. And how do you find the maximum or minimum? It is the y value, or the y coordinate of the vertex. How do you find the zeros? Well, good question would be, what are the zeros? What is a zero? And a zero is also known as a root. And if it crosses the x-axis, it's x-intercepts. And we will use those words interchangeably, and you find them the same way you find a root or an x-intercept, which is to let y equal 0 and solve for x. Well, let's do our first example. We want to start with finding the vertex. And so we're going to find our x first. And x is negative b over 2a. Now b is 4, so negative 4 over 2. And so our x-coordinate is negative 2. Now to find y, we are going to substitute y f of negative 2. And this gives us 4 minus 8 plus 1. So negative 4 plus 1 is negative 3. So our vertex is negative 2, negative 3. Now the domain, that answer never changes. Always infinity to negative infinity. The range depends on if it's opening up or down. This one is opening up, which means we have a minimum, which means we're going to start with our negative 3 and open up to infinity. Now the zeros, I'm looking at our equation, and we can't factor this. So the way that we're going to find this is by using the quadratic formula. So we're going to substitute into the quadratic formula, like that. And when we simplify this, we get negative 4 plus or minus the square root of 12. 12 is 4 times 3, so that means we'll have 4 plus or minus 2 square root 3 over 2, and that means negative 2 plus or minus square root 3, and those are our roots. Now, we need to graph using 5 points, so we're going to make a t-chart. And we're going to center it at negative 2, negative 3, and find some points around it to use. And I'm going to start with 0. So I put 0 into my function. I get 0 plus 0 plus 1, so it's just a 1. Then I'm going to go to my negative 1 and substitute that in. So that gives me 1 minus 4 plus 1. And that gives me negative 2. So, yeah, negative 3 plus 1 is negative 2. So, negative 2. And these are also metric around the vertex, so that means this is negative 2, and that's a positive 1. So, to graph this, I'm going to switch colors, and we're just going to plot the points. So, my first one is negative 4, 1, so right here. And then my second one is 3, negative 2, that right there. And then negative 2, negative 3. And it's like a mirror around this, so it's pretty easy to graph. And then we just connect our dots. Okay. Now on your real graph paper with your real pencil, you will end up hitting the lines where you're supposed to. Let's go to the next example. Okay. Now, the vertex. negative b over 2a. So I'm going to give myself a little bit more workspace over here. So negative negative 6 is a positive 6. Divided by 2a, so that's 2 times 3, which is 6. So there's the first part of my vertex. So the x is 1. And that's what I want to substitute into my function. So f of 1, 3 minus 6 plus 5. So 3 minus 6 is negative 3. And negative 3 plus 5, that's 2. So 1 comma 2. And the domain never changes. It's always negative infinity to infinity. The range, this one points up. So we're starting with our y-coordinate of our vertex. So it starts at 2, goes to infinity. And then for the zeros, I'm not sure whether this one factors or not. So I'm going to use the quadratic formula. So quadratic formula, so 6 plus or minus the square root of 36 minus 4 times a times c. So 4 times 15, that's 60. And look at the determinant, the number under the radical. I see that I'm going to get a negative number. So while I do have zeros, I'm not going to have x-intercepts. So this appears to be negative 24 over 6. And negative 24 simplifies to 4 times 6. So that's 6 plus or minus 2i square root 6 over 6. And that will simplify to, we can take a 2 out everywhere, which leaves 3 plus or minus 2i, no 2, plus or minus I square root 6 over 3. And those are our zeros. They're imaginary. And imaginary means that they have roots, they have zeros, but they don't cross the x-axis. They're not x-intercepts. So let's do our t-chart. And we're going to center it at our vertex, 1, 2, and pick some points around it. And I always like to start with my 0, so I put my 0 in, it gives me a 5, which means this is also 5. And I'm going to put in negative 1, and that gives me 3 plus 6 plus 5, which is 14. So this one's going to go off the grid. That's okay. Okay, so we've got our vertex at 1, 2, right there. And 0, 5, 2, 5, and then 14's way up here somewhere, like that. We're just going to graph it the best we can. So our graph looks something like this. And that is this section.